Hey guys, welcome back from spring break. Just going to go through these notes real quick. Got a little bit of time here with the kids being down for a nap, so I'm just going to talk about solving exponential and logarithmic equations. This is what you guys are focused on for the remainder of this week. I know it kind of seems like a little bit of homework, but just keep in mind that all those free responses, that's probably something that we would do in one class period during the day. So just stay on top of that work and just make sure you guys get that to me by Friday. Next week, we have one more topic talking about graphing logarithmic equations and what that looks like. And then we will be able to really wrap up our log unit and then move on. So we'll probably be having another quiz next week at some point. But solving exponential and logarithmic equations, we kind of talked about exponential equations a little bit already. But really the main idea with this, and if we look at these directions right here, the first thing that you really want to do is to isolate the exponential expression or isolate the logarithm by itself on one side of the equation. So if I'm dealing with an exponential equation and they give you an example there, 3 plus 2 to the 3 minus 2x, there's my exponential expression. Basically, it's where your exponent has a variable that is involved. So I would really need to isolate that base of 2 with my exponent by itself. So if I subtract 3 from both sides, that's a good starting place. 2 is equal to 3 minus 2x is equal to 8. If we think back to our exponential unit, we had a couple of problems that showed up, and I know that was one of them when you guys were working from home already, where we had basically two exponential expressions, and you guys were asking, you guys didn't know how to solve that because there was no way to rewrite both sides in the same base. So I was telling you, you had to graph both sides of them and then figure out where they intersected. This is kind of the very beginning part of this. We're going to have one of those questions later about how to solve that with logarithms. So I know very well, like I could look at this problem here. I could rewrite 8 with a base of 2. It's 2 cubed. So then I would have both sides rewritten so it does have the same base. So I could really drop the base out of the equation from both sides and just set my exponent equal to each other. So I'm going to write here. Let me get out my pen tool. We could really easily have, instead of 8, we could have 2 cubed. So I could set 3 minus 2x is equal to 3. We can solve from there. And I'll still get x equals 0. But this is how you use logarithms. So what we are going to do is once you have your exponent, your base with your exponent, your exponential expression isolated on that side, you are going to logarithmitate both sides of the equation. And that is a new term for us there, logarithmitate. Basically, we are going to take the logarithm of the base of my exponent on both sides. And I'm going to use properties of logarithms to really get this 3 minus 2x out of the exponent and then really bring it down. So you can see here, they took the log base, and since my base is 2 of my exponential expression, notice here that my base now of my logarithm is that same number. Because if I have log base 2 of 2, that's really going to cancel out, and you're going to be left with just whatever your exponent is. So since I take log base 2 of the left-hand side, I really need to take log base 2 of 8 on the right-hand side. This is why we're really going to have the same answer, because if I look at this expression right here, log base 2 of 8, 2 to what power would equal 8? Well, the answer to that is 3. So once we do that, then basically the rest of it's from there. If I move down here to if an exponential equation, that's really the same deal. All right, so let me just go through this here. If an exponential equation only has one exponential expression, which this one does, that's what we're talking about. If an exponential equation has an exponential expressions on both sides of the equation, rewrite each side of the equation as a single exponential expression that have the same basis. then you can logarithmic both sides using that same base and then solve the remaining equation for x. So we really just have some examples from here of just solving some problems of some exponential expression and some logarithms on the next couple of pages. Let me get back here, scroll down. So here, my first example here is I have 3 e to the 2x plus 1 power. So the e to the 2x plus 1 power, there's your exponential expression. So I would need to isolate that by itself. So that's why they divided both sides by 3 to get 4. So now we are going to logarithmic from here both sides of my equation. So we just have to remember, if I'm taking a logarithm that really has a base of e, that is a natural log. So at this point, they took the natural log of both sides of your equation. And whenever you have the natural log and e kind of showing up right next to each other, they cancel out and you're just left with the exponent. And then over here on the right-hand side, I have natural log of 4. It's best that's not going to come out as a nice, rational number. So I'm going to leave the natural log of 4 as part of my answer for now. And subtract 1, divide by 2. I would be perfectly okay with this as an answer. You can type it into your calculator. You're just going to have to round. The only thing I would just say to be careful of would be that natural log of 4 minus 1. When you type that into a calculator, it's going to tell you the natural log and then it opens a set of parentheses. When you type in 4, you need to make sure that you close the set of parentheses around the 4. If you type it in as the natural log of, and you just type in 4 minus 1 and then divide it by 2, that is not going to be taking the natural log of the correct number, because basically your calculator, if you typed it in like that, is going to kind of group all of that together. Now, I know some calculators are a little bit different, so just be careful when typing that in terms of where the parentheses are and making sure that you actually get the correct number. That next example over there, the 2 to the 3 minus x power plus 4 is equal to 10. The first thing you need to do is isolate that exponential expression, which they did by subtracting 4 from both sides. So now I have a base of 2. So what we would do is we would logarithmic both sides. So we would end up with log base 2 of 2 to the 3 minus x. That would just leave you with 3 minus x. Over here on the right-hand side, log base 2 of 6 is not going to come out as one of those really nice numbers that we have, because 2 to a power would not give you exactly 6. It's going to be 2 point something. So that's why they're leaving it as log base 2 of 6, and then you subtract 3 from both sides, and then divide everything by -1. That's why -3 becomes +3, and instead of plus log base 2 of 6, we have minus log base 2 of 6. This next example right here is pretty much the same. So I want to talk about this one to the bottom right. There's really not a tricky part about that or anything nothing wrong with this problem. The only thing is, if I rewrite both sides, previously we would have stopped right here at that 2 to the 3x minus 3 is equal to 2 to the 3x plus 4, because at that point, both of your sides of your equation is rewritten so it's the same base. So you could really just drop the 2 immediately right there and just set the exponents equal to each other. The reason why it's no solution is because that equation that's left, 3x minus 3 is equal to 3x plus 4. If I tried to subtract 3x from both sides, we would end up with 0x, and there's nothing left to solve for. And they're showing, divide both sides by 0. That's why it's no solution. So it is possible to get no solution. All right, so if I want to talk about this problem real quick, here on the left, we basically have, it almost looks like a quadratic equation. I have e to the 2x minus 4e to the x minus 5 is equal to 0. So this is a problem that we could really solve by factoring, because if we think about e to the x times e to the x, I would add the exponents and I would end up with e to the 2x power. So basically, I'd be looking at, all right, since I have -5 there in my ABC method, what are factors of -5 that add up to -4? And that is -5 and +1 right here, -5 and +1. So those types of problems where you end up having like e to the 2x, and then you have e to the x, and then a constant, we're really going to solve that by factoring if we can. And then they're just going through the steps there in terms of actually solving. This one right here, the reason why it's crossed out is you cannot take the natural log of a negative number. So I want to talk a little bit about this problem here on the right, because this one's a little bit unique. And this one goes back to, hey, what if you have an exponential equation and both sides of your equation cannot be rewritten as the same base? I mean, obviously, I got 2 as one base. I got 5 as another base. There's no way to rewrite 5 so that way it's a base of 2. So at this point, we're going to go ahead and logarithmitate both sides of my equation right off the bat, because I really want to do something that I can get, that x plus 2 and the x minus 3 out of the exponents. So what we can do is we're going to take the natural log of both sides. So by doing that, we have a property of logarithms that allows you to take the exponent and bring it down in front as the coefficient. Okay, so we end up with x plus 2 times the natural log of 2 and x minus 3 times the natural log of 5, which is what they have. So now that I have an equation, I have x on the left-hand side, I have an x on the right-hand side, we really need to do some stuff to get the x's to the same side, because I want to solve for just one x and not showing up in 2 different places in our equation. So if I do have terms that have an x in it in 2 different places, if I isolate those terms on one side of your equation, then I'm going to end up being able to factor out an x out of those 2 terms, and then I can solve for that one x that remains, which is basically what we're doing here. So over here on the left-hand side, I'm going to just take natural log of 2, and I'm just going to distribute. So I have x natural log of 2. All right, there's one term that has an x. Plus 2 natural log of 2. That does not have an x. On the right-hand side, distributing natural log of 5. I would end up with x natural log of 5 minus 3 natural log of 5. So I got 2 terms there that have an x in it. Even though they're on both sides of the equation, I really need them to be by themselves on one side of the equation. So what they did is they subtracted x natural log of 5 from both sides. That would give you this. But I would also have the 2 natural log of 2 that's left on that left-hand side. So they went ahead and took this and moved it to the other side as well by subtracting 2 natural log of 2. So if I look here, that right there, I have 2 terms that have an x. So if I factored out an x, that's what we would have right here. X times the natural log of 2 minus the natural log of 5. Then all I have to do is get x by itself. Since x is being multiplied by natural log of 2 minus natural log of 5, I would just divide both sides by natural log of 2 minus natural log of 5. And there is our answer. That problem right there and how to do that would be looking back to the last unit. The problem that I was talking about at the very beginning today, where we had, hey, what would you do if you cannot rewrite both sides of the equation as an exponential expression with the same base? This is how you would do that problem using logarithms. You still have the option of just graphing the left-hand side, graphing the other side, and seeing where they intersect. That's still perfectly okay, but this is how you would do this problem using logarithms. Really moving forward, if you have multiple logarithms like this example right here, I have basically 3 terms, natural log, natural log, natural log. Can I get it so that way it's just a natural logarithm equaling a natural logarithm? If that's the case, then all you would have to do is basically set the arguments equal to each other. x squared plus 2x is equal to 8 in this case. So then it just turns into a quadratic equation. And then solving it, the negative answer right here, we could not use, because if you plug the negative in right there, you'd be taking the natural log of a negative number. So that would not be one of our solutions. All right, scroll down here to this last page of notes. I'm going to go through this pretty quickly because I got something coming up at 1. Over here, this first problem, rewrite it so that way it's just a single logarithm on the left-hand side. Since it's minus, it means I have to divide my two arguments. Then basically what I would be doing is rewriting it as an exponential equation instead of a logarithm. 2 to the third power, which is 8, is equal to this argument. And then to solve from x in this case, you just have to cross multiply and then get x by itself. This next problem right here is pretty simple. We have a single natural logarithm is equal to a single natural logarithm. You can basically just set the arguments equal to each other. That's the only way that those two things would equal to each other is if x plus 3 is equal to 2, and then you just solve and your answer is negative 1. This next one here, isolate the logarithm by itself. So I would need to add 3 to both sides. And then basically all I would have to do from here is just rewrite it as an exponential equation. 3 to the fourth power is 81. And then it's going to be equal to my argument 2x minus 1. What they're doing, just like before when I was saying logarithmic both sides of your equation, this would be exponentiate both sides of your equation. Basically taking whatever the base of your logarithm is, and now I'm making that the base of my expression, and then all of the rest of it would be in my exponent. But really, I'm just rewriting it as an exponential equation. 3 to the fourth power is equal to my argument, and then I can just solve it from there. Couple examples left here. Let me erase this stuff so I can scroll down. This next one here, I got 2 logarithms on the left. I got 1 logarithm on the right. Rewrite it so that way I just have a single logarithm equaling a single logarithm, which is what they did. Since it's plus, that means I have to multiply the two arguments. So x times x plus 3 would be x squared plus 3x, and it's equal to log of 10. The only way that those two things would be equal to each other is if I just set the arguments equal to each other, which is what they did here. And then I'm just solving that equation from there, and then just make sure you check your answers at the very end to make sure that when you plug them back in, you don't end up taking a logarithm of a negative number. This example here, next, same thing. Rewrite both sides as a single logarithm. So since there is a minus sign right here, I would have to divide the two arguments. That's why they have x minus 3 over x plus 1. And then on the right-hand side, since there's a minus right there, I end up with 3 divided by 7. So now that I have a single logarithm is equal to a single logarithm, both of them have the same base within the logarithms. I'm just setting the arguments equal to each other, which is right here. Solving that problem, cross multiply, and then solve. The last one here, I would need to isolate my logarithm by itself, so add 3 to both sides. And then I'm going to basically rewrite this as an exponential equation. So I would have to rewrite this. The base of the natural log is e. So I have e squared is equal to my argument. And then I'm just solving. Add 1, divide by 2. There it is. All right. So if you have any questions about that, I know I went through that extremely fast, but just keep in mind you can always rewind and rewatch it if you need to. Please email me if you have any questions. Other than that, I'll look forward to seeing your guys' work, and welcome back from spring break. And just make sure you reach out if you have any questions. If you need to reach out through Google Hangouts as well, I can sit there and you can show me your work and kind of talk through about what you're doing. But just let me know. Take care, guys. Stay safe.